Welcome to Convergence. My name's Mike Doran, a California attorney. Don't have a dog in the hunt. Albert Einstein said that among the most difficult problems in all of physics is the Earth's magnetic field. As a California attorney, I'm going to argue that among the most difficult problems in all of biology is the Earth's magnetic field. Biology today is a mixture of agriculture and then natural settings that the biosphere over billions of years has given us to solve the problems of inputs into the Earth's system. And the biggest problem fundamentally that life has had to deal with is stuff from space. And it's not something we normally think about because it's such a massive scale that you don't think about, it's not just the movement of the Earth around the sun or the moon around the Earth, it's also things like cosmic rays and the position of the time of year when cosmic rays are highest, when the sun is the most active, and so forth. And right now, we are moving out of a time of a quiet sun and into a more active time with the sun, and that has an electrical significance. And on top of that, electrical significance can move around the Earth depending upon where thunderstorms and where tropical storms and where the feedbacks that are occurring happen. And in this particular case, the big news today is a fire called the McKinney Fire, which is in northern California. It's moving towards Wairika, California, and this is kind of an update show on what's going on there from this perspective of not meteorology really, not firefighting, but what space weather is doing and what the electrical conditions are doing that would enhance or not a fire. So yesterday, the show that I made was talking about incredible clouds above the fire that was really causing explosive growth. Of course, there are factors like whether the area being burned hasn't had a fire for a while, whether the part burned has been cut before so that there's open spaces where spotting can occur. But what I didn't talk about was how there were thunderstorms in the area. And if you go over the thunderstorm, the worldwide lightning network out of Washington University, and you just watched it, which I did several times, I watched the movie version of it on that website, and you look at what's going on with the fire, you can actually see the smoke coming off the fire, moving at this particular time, maybe 22 hours ago. So in the afternoon of the fire, you can see the smoke moving to the north, or just north by west a little bit, but mostly north. And then you see thunderstorms forming out of the smoke. And now there's a report of another fire. So not very big, not as big as this McKinney fire, but there's another fire that's burning. And this is a way that fire can spread even no matter what firefighters are doing. If you get these kind of behaviors, you're going to have lightning and another fire. So that's an interesting development. The space weather conditions are fairly close to the same as they were yesterday. There's in my review here a couple things that I have to say about it. So, I want to be precise. So currently, solar wind is 458.5 kilometers per second. This is from spaceweather.com. X-ray flares, just a B level. This falls nearly an M class about 3 days ago, which kind of fired this whole thing off in terms of intensifying 2 tropical storms. One became a hurricane, and the other there's this effect that 2 tropical storms will rotate around each other in a counterclockwise direction, and one of them is moving a little bit more towards is moving south a little bit more, and the other one is moving up Baja. And it was even more strong yesterday. I believe the fires and then the thunderstorms all work together regionally to help intensify these storms. Everything gets intensified. But there's 2 factors. There's carbonation, and you get decarbonation with surface low in the tropics. And then there's also the amount of electrical currents that are involved. There's a rule of thumb in static fields that the strength has to do with the inverse of the distance squared. And maybe if you're familiar with any electronics, you see it when you have a direct current and you see a power drop with distance. And that's one of the reasons why we use alternating currents, is because they can go a longer distance and carry energy a longer distance without as much of a power loss. Well, right now, if you go to the Null Surface Wind website, which is an unbelievable source of information from my perspective, you can see undulations when you blur it a little bit. In other words, you take your cell phone, okay, and you take your cell phone. Let's see if I can get right to the picture. So this is the picture that I was looking at. You take your cell phone and you move it a little bit, and before it loads up, you get kind of a blurred image, and you see the tropical storm right off Baja. It's right on the latitude line, and it's just a little bit by latitude where the Gulf of California or the Sea Cortez starts. But starting in Baja, there is a perfect undulation that literally runs all the way to the McKinney Fire right now as I'm speaking. And so if it might be hard for you to, it might not be there because we're pretty close to the peak of lightning right now. But when you watch this video, you might be able to see it. I might even put this as I get concerned about copyright, but I might put this on the front of the video so you can actually see it. It's just remarkable. And so what we're talking about is not only do hurricanes have this microphysic effect where the carbonation gets up into the clouds, right? And then you have low pressures. It's hard to create a low pressure. It requires energy in a vacuum. It's hard to create a high pressure. It requires a force compressing the air. It's hard to put a lot of negative charges together. It's hard to put a lot of positive charges together. And this complexity, this electrical complexity, is held together by water, because water is a very powerful dielectric, and water has this microphysics effect when it's carbonated. And it has to do with how fast phase changes occur from water to ice. And tropical storms have a lot of ice in them. And believe it or not, on the top of fire clouds, you have the same phenomenon you have at higher elevations. You get the very cold air up above the fire, and you have smoke, which is carbonation and water, and it freezes. And if there's electrical fields, depending upon how strong they are, you're going to get organization based on the carbonation in the fire. And this is happening in the entire region. So what can you say kind of from a forecast standpoint? Well, what occurred on the sun to bring us the pretty extreme X-ray event, at least for where we are in the sunspot cycle, also there's a coronal halt and there's instabilities, and we're starting to elevate a little bit with the solar winds. And once it gets over 500 kilometers per second, it's much harder for tropical storms to have this electrical organization and to stack and to vent. The other thing going on with, I believe it's Frank, is that it's starting to move over cooler waters. And what the so-called experts are saying it from the National Hurricane Center is they're forecasting it based on their models to weaken. And as it weakens, there's a couple things happen. Like any capacitive coupling, when the plates go away, capacitance goes to zero and voltages go to infinity. It's just another way of saying charges have to go someplace. And that tends, in my observation, to create a lot of local lightning. Not with the storm, but around the region where this occurs. But it's kind of a one-time deal, and then you don't get the same kind of organization because the storm isn't decarbonating and bringing relative carbonation to the whole region. And so the fire, as we plot it over the next couple of days, of course there's going to be firefighting, but the conditions are going to be less conducive over time slowly as those tropical storms peter out. And then space weather is going to start to be disfavorable. There won't be a recent X-ray event, and then you're going to have higher solar winds. Cosmic rays as a factor is slowly going away. But right now, with the peak of lightning, there's undulations running from that tropical storm all the way to the fire. And the whole area basically is seeing some monsoonal lightning, and the fire behavior is being enhanced a little bit by this. Maybe not as bad as it was yesterday, but it's still not a good situation. But improving from a space weather standpoint. And if I might, I'd like to get into sort of a related topic. I spent the day looking over Afghanistan and the Aral Sea and just looking at the region, which is in horrific drought right now. And it's similar to the the dry conditions that we're seeing here in California. And Afghanistan in particular is in a horrific drought. And it's very much like what we're seeing with the Great Salt Lake in Utah, where it's at record low levels. And all around that area you have dams that are being put up to irrigate mostly alfalfa in the Utah area, and you're seeing high levels of fertilizers in these alfalfa fields. So when it does rain and when there is offlow from those fields and it goes back and it runs down to the Great Salt Lake, it's putting fertilizer in the lake and changing the behaviors of the blooms, of the microbes that are in the Salt Lake. And so, and then as the water levels drop, you're also it has a biological effect on what's going on there too. So there's two things. There's the conductiveness of salt water, and if you have a smaller plate of salt water, you have a smaller source of moisture that can be fed back into river systems, and And then if you have biological changes, you might get heat feedbacks at the wrong time, and especially with dams, that the rain comes, but that's not what flows into the Great Salt Lake. It gets caught by the dam and then released during the dry season, and that's what we're seeing now, where the heat feedbacks that are occurring, and maybe the thunderstorm enhancement is occurring right now when it's 110 degrees and record heat is being created by these feedbacks rather than, and that's what happened up there by the fire. Wednesday had record heat, 110 degrees, and nowhere near normal, and that doesn't help your fire behaviors, of course. But what I'm trying to say is these defects in feedback loops that affect timing of when feedbacks are occurring, if it's not during the rainy season, say in January and February, then during that time of year, there's no rain when there should be rain, and then when it's hot, you're having these feedbacks, and they're making it hotter. And the biological purpose of this is if you have a snowball Earth, no life exists. So over huge time scales, the biosphere has learned how to do these decarbonation events that provide heat feedbacks, not just a greenhouse gas, but more like a dynamic, just like when you're pumping up a bike tire, it warms up. It's a warming feedback. Even the ashes from the fire are going to get over white snow and help melt it more. The whole biological purpose of these trees and fires is to stop a snowball Earth. And so when you have these dams that are releasing cold water, even when they're almost empty, during the dry season, the biosphere thinks it's snow in the mountains and it feeds back heat. So back to Afghanistan. There's the drug trade, the morphine, the poppy trade, and there's been dams built and siphoning off of the river systems that flow from Afghanistan to where the Sea of Aral is. There's inland seas that Afghanistan has itself, also subject to very similar changes, just like the Great Salt Lake is. And so like when the Sea of Aral was killed around 2000, I mean, it just dried out. The extreme salinity that occurred because of this killed everything in the Sea of Aral. I mean, killed the fish, killed plants, everything, insects, and then in 2005 they built a dam on the northern part of the Sea of Aral, and then we're very careful about letting at least a small portion fill back up with water, and they put fish in it, and they created a more or less living area, and maybe that's good, maybe that's not, but the point is that we're creating these artificial ecosystems that have these effects, and we don't realize what they're doing. A good example is the Green River. There's a massive dam on it, and I have a friend who just loves fishing, and he talks about there's like a 10-mile stretch of some of the best trout fishing in the world beneath the dam. So instead of during rainy season where you would have flow coming off these steep embankments and making a muddy river, and that muddy river flowing eventually down to the Gulf of California, and where there's methane hydrates, and you get these feedbacks during the rainy season, what instead you have is much less erosion into a reservoir, and then the reservoir during the dry season releases, and then you get this ecosystem of trout The trout go to the bathroom, they fertilize that area, allows for plants. The plants grow, bugs start to come in there to eat the plants, then the trout eat the bugs, and you get this perfect area of 10 miles of trout fishing. But that's not natural. The mountains don't have snow in them. You would create the conditions naturally for trout to exist. This is conditions created by a dam. And so similar thing is going on in the sea, the northern part of the Sea of Weddell. But then you still have fossil fertilizers that are starting to be used in farming, not just in that area, but the whole region. If you're talking about the Black Sea, you're talking about the Caspian Sea, you're talking about Pakistan, where they're damming major rivers that flow out of the Himalayas and then eventually make it south into the ocean down there. All this is affecting how decarbonation events. Even Saudi Arabia, there's a natural amount of water in an aquifer that is very ancient, comes from during the glacial, and they're pumping that aquifer out. It's almost depleted already, and they're having irrigated farms that are kind of a temporary solution for maybe their food needs. That also affects the whole area in terms of where displacement currents from lightning go, and what actually is used of this energy to influence cloud behaviors. So that entire area is been so changed and so artificial, and now Afghanistan is millions of people are going to starve, I think. I mean, I just don't see, there's no, it's an absolute disaster there. And here the United States military spent so much money there and to try to stabilize this situation, and climate is just going to destroy all that stability. And it's not climate that is not related to human activity. It's entirely related to human activity. And a lot of it is the United States' responsibility in terms of banks and lending money to build these dams, not knowing that in the long run they're a complete disaster. They're money makers, right? You get power out of them, and you're gonna be able to provide irrigation to farming, and so there's benefits, and you can bank on it, but the long-range picture is horrific, really. And we need to start looking at when dams are released, should we even build them, what the sedimentation is coming out the back side of them, because the sedimentation affects the health of the methane hydrates in, say, the Gulf of California. These fire behaviors that we're starting to see, that's part of the dampening too. It's carbonated clouds. It's the same thing. Fossil fuel use is a signal noise problem. We carbonate the air so much that you're not able to get a signal out of these feedbacks. And then finally, the fertilizer problem. And that's also an unsustainable thing, because we're going to run out of fertilizer. That's not natural, and for instance, nitrogen fixing from lightning. It's just a not sustainable, certainly not in our lifetime. It might be 300 years that it takes for 7 billion people to use up all the fertilizer, but it's just not sustainable. And we need to start thinking about all these different things in an electrical way, ultimately modulating or dampening the Earth's magnetic field. All right, well, thank you. If you like this update on the fire, and just my riffing here a little bit about the overall problem, please like. If you want to subscribe, I would love, occasionally as these extreme events come up, We're right about ready to get into the meat of the hurricane season, and I definitely have something to say about space weather. And you know, you get an X-class X-ray right in the middle of the tropical storm season, and the setting is right. You're going to get rapid intensification, and I want to report these things to you, and point out the real issues with climate change, with the proper mechanism being discussed, not just the greenhouse gas. The greenhouse gas theory might be a little bit of an input, but ultimately it's incorrect because the Earth is alive. It's a dampened system. Greenhouse gas alone it takes 600 years to get CO2 out of the environment. It takes too long for it to be by itself a meaningful feedback. But as a greenhouse gas is a signal noise problem, carbonation is all about enhancing these cloud behaviors. It is important, but we have to talk about mechanism, because otherwise we're not going to properly talk about what's going to work and what's not. You can plant 1 million trees, but if there's no water, they're not going to grow. All right, thank you, and good luck.